So next program 4, develop a program to implement simple linear regression model and evaluate the model by verifying the performance. So first you have to import a package pandas SPD. Then we have a data set called salary underscore data.csv. You have to read that data set by using pandas. So for that, pd dot read underscore CSV. This is a CSV file. So the CSV file you can download from Kaggle or any other, in Excel also you can create. So if it is an Excel, you have to give dot Excel SX, and instead of CSV, you have to give Excel. Then after that, I'll read underscore. So this particular data set is going to assign to DF. And this DF, if you want to see the data set, df.head we are using. So head function will print the first 5 rows of the data set. So once you execute, you can see the first 5 rows you will get. And also 2 columns are there. One is year of experience and salary of employee. Next one, just I'm printing the shape of the data set, that is 30 rows and 2 columns. Next, I'm going to initialize x and y. So in linear regression, you know that the equation is y equal to mx plus c. So this x and y first you have to declare. So x is what you are going to x is what by independent variable, and y is y is dependent variable and x is independent variable. So x we have to, here you can see salary is dependent years of experience. So years of experience is going to store in the variable x. Okay, so by removing the salary, we will get the values year of experience. So df dot, by using drop function, we are dropping the salary, and the remaining column is year of experience storing in x. Then y is used for storing salary. So df dot salary. So axis is equal to 1 indicates the column. Then just I am printing x dot head. You can see only years of experience is there. Y dot head will print the salary. Then after that, we are going to apply linear regression. For that, you have to use a package called scalar.model underscore selection. In that, we are going to import train underscore test underscore split. So this data set is going to divide it into train data and test data. So train data and test data. So 30% of data in the data set is moving to test data. So that we are indicated by using test underscore size is equal to 30. 0.30. Random status for each and every execution, same type of data, it is going to assign for test and train data. That is equal to 0. Then x and y, and the function used is train underscore test underscore split. So this function will divide the data set into train data and test data. And it will give x train, x test, y train, and y test. And just we are printing how much data is there in x test. So 9,1, that means 30% goes to test, remaining train. Then we are calling linear regression. So linear regression function is defined in linear regression package, and the package is defined in scalar.linear model. And by using fit function, we are going to pass x train and y train, and we are executing, and we are passing x test in predict function. And it is storing in a variable called yPredict. When you're printing yPredict contains the value for x test. So yPredict contains going to predict for x test value. And we are printing y test also. Next one is we are going to evaluate this by using r square underscore score. So almost 97% of data is we predicted accurately. And by using mean absolute error also, how much error it is there, like that you can find. But r square underscore score is enough for finding the accuracy. Then, if you want to predict a new years of experience, if you're given, it will predict by using linear regression. It will predict almost a salary. You will not get full accuracy. Almost 97% accuracy is there. After that, we are going to plot this one by using a rect plot, and this rect plot is defined in z-born, and c-born is imported here, and by using that, we are plotting. So this is linear regression. For each of every year of experience, what is the salary? We can predict by using simple linear regression. And y equal to mx plus c. That is, develop a program. So we developed a program to implement simple linear regression model and evaluate the model by verifying the performance.